Okay, so this one is about circles, which you know a bit about anyway. I'd like to get rid of radians, well, from everywhere for all time, but I can't even get rid of them for this course actually, because in polygons, generally the rules are listed in degrees. But let me talk to you briefly about radians. So, way back in the day, when people were trying to come up with a relationship between the diameter of a circle and the circle's circumference, they discovered that it was irrational and they kept trying to approximate it. And once they realized it was irrational, then they gave it a name. Anytime a number has a name other than, like 32 fifths or 12, it's because it did something special in nature. So in this case, they named it pi so that if you know the diameter, then the diameter times pi is the circumference. So this isn't, lucky or magic. That's what pi was defined to be right from the beginning. It turns out also that area is pi r squared. And you've probably seen the circumference written 2 pi r. So the diameter is 2 times the radius. So a diameter is, well, first let me say a chord is something that goes from one edge of a circle to another. But if it goes through the center, so it's like the longest chord, then it's called a diameter. And a radius starts in the center and goes to the edge. So if you put two radii together in the same line, then they make a diameter. So 2 times the radius times pi is another way to say circumference, just because diameter and 2r are the same. And then people write it this way. So pi r squared is the area, 2 pi r is the circumference. So in calculus, there is a method by which you can measure around, well, any arc really. You can measure the length of whatever, if you can write it as a function. And a circle, as you know, is y squared plus x squared is r squared. So that's like two functions, but it's a parameterized curve, meaning neither one of these is a function of the other. So we can write it down. And if you can write it down, then you can measure it. So the first thing is degrees were originally defined because the people of the time believed that it took 360 days to go around the sun. So they measured it in a go all the way around sort of way, and they decided each degree would be a day, basically. Of course, we know that it's 365 and a fourth days to go around, so even their original thought process was faulty. But when you get to calculus, you can set it up with an integral to measure around a circle. And if that circle has radius 1, then the result you get is the sum total of the angle measures. So this is defined in terms of trig functions, so that you end up with total sum of the degree measure as your result. So if this is all 360, then a circle of radius 1 has circumference 360. Well, it doesn't. A circle of radius 1 has 2 times pi times 1 as its circumference. So if math is going to be accurate, then the sum total of the measures, instead of 360 degrees, should be 2 pi. So this is what radians does. Radians makes math function. It also makes physics function. If you deal in radians, a lot of things are clean and pretty that with degrees aren't, because this is the natural measure. So all the way around 2 pi. So 360 degrees is 2 pi radians. So I could write radians there. If you want to convert then, so let me erase 2 pi radians equals 360 degrees, which means 360 degrees over 2 pi radians is 1, and also 2 pi radians over 360 degrees is 1. And you've probably studied unit change factors in maybe 8th grade, so things where you want to know, you've got 574 inches and you want to know how many feet that is. And so you write it as 1 foot over 12 inches, and then you're just multiplying by 1, and that's perfectly allowed, and then you cancel these out. So similarly, if I have degrees and I want radians, I would multiply by 2 pi radians over 360 degrees, but this can be simplified. So instead of doing that, we do 180 degrees over pi radians, so I've just divided by 2 on top and bottom, or pi radians over 180 degrees. And generally speaking, we don't write radians, but that's what we're doing. So normally though, we would just multiply. So if I have, say, 90 degrees, and I want to know what that is in radians, then I multiply by pi over 180 degrees. The degrees symbol cancels. 90 over 180 is 1/2, so this is pi over 2. The measures that we normally deal with then on the special triangles, so this is actually something you'll use more in pre-cal, but I'm introducing it now because it has a bearing on the thing about circles. So if I have these 3 kind of special ones, so this is 45 degrees, 30 degrees, 60 degrees, this is pi over 2. 180 degrees is pi, that's why we have 180 in pi on those fractions. So if you multiply these by that unit change factor, you end up with 30 degrees is pi over 6, 45 degrees is pi over 4, and 60 degrees is pi over 3. So these are the ones, and this is 0, it's also 2 pi. Pi over here, 3 pi over 2, pi over 2. Okay, so this was just, I don't know, a soapbox, but it is relevant, and it's something to think about when you're figuring out things to do with circles. So the things we want to know about circles are how radii and diameters are related, which we just talked about, the area and circumference, which we just talked about, and from those, so we know the whole circumference is 2 pi r, and the whole area is pi r squared. And a chord, again, a diameter is a chord, but a chord can be short. It doesn't have to be a diameter. Diameters have to go through the center. So if I wanted to talk about instead some arc length, so I just want this measure here, then if I know what this angle is, in degrees, it's a little bit of a beating. If I know what that angle is in radians, it's pretty simple. So first let me talk about suppose it's given to you in degrees. So suppose that's given to be, I don't know, what does that look like, 55 degrees? It's going to make a clunky radian. So let's say it's 60. It's pretty close to 60 anyway. Let's say that's 60 degrees. So what we would do is say, okay, if I know this radius to be, say, 2, then the circumference equals 2 times pi times 2. So the circumference equals 4 pi. But I don't have all of the circumference. So I have 60 over 360 of the whole circumference. So 60 divided by 360 times the circumference. So then I get 1/6 times 4 pi, so 2 over 3 pi. Okay? Suppose instead I looked at it in radians. 60 degrees, as we just noticed, is pi over 3. So we just discussed that. So look at the relationship between these. This is twice that. My claim is the 2 actually came from the radius. That any radius I put in there, if I just multiply it times the measure of the angle in radians, then I'll get that arc length. So if I have another circle, and let's say this time the radius is 5. And let's say this time I get 120 degrees. Okay, 120 degrees is also 2 pi over 3. So I'm going to just say this is 2 pi over 3. So also 120 degrees. Okay, so I have an entire circumference of 2 pi times 5. All right, this is my circumference. So if I now say, instead of 120 out of 360, I say 2 pi over 3 out of 2 pi, because that's now the total. So this is the portion I've got covered here on this little arc length. So what happens is this 2 pi and this 2 pi, which came from the same place in nature and exist for the exact same reason as each other, they cancel. So what I get is 5 times 2 pi over 3. Radius times angle. So if we can deal in radians, then all we have to do for arc length is the radius times the measure of the angle. And I personally would rather always deal in radians because they are functional measures. So this leads to a fairly easy arc length calculation, where in the past you may have calculated arc lengths and had to figure out portions of 360, and then you multiply by 2 pi and you get more of a mess. Okay, so you might suspect then that there will be a similar situation with area of sectors. So what we just did wow, that's a horrible circle. Try that again. Okay, so what we just did was an arc, the length of an arc, which is a portion of circumference. So arc. And we calculated the arc length. Another thing that you need to know how to do with circles, if I take the center and I connect it to the edges of an arc, so it's like a slice of the pie, this is called a sector. And I might want the area of a sector. So let's once again use the radian measure. So this looks like, I keep making them too close to 60. Let me just go ahead and make it 90. Okay, so you would know that that's a fourth. So if the radius, let's say the radius is 3, you would know that the total area was 9 pi. So that's plugging this in here. So the area of the entire circle is 9 pi, and you know that this is a fourth because this is just an angle measure you're used to. So the area of this sector, so area of the sector, equals 1/4 of 9 pi. Okay, but let's suppose you weren't that used to it and you didn't see it that clearly. You would have had to write 90 over 360. That would have changed to the 1/4, and here we would have been. So let's say instead that I'd given you the angle pi over 2, which is the same. Then the area of the sector would have been pi over 2 of 2 pi. See, this is still a fourth. The pi's cancel. The 2's both end up on bottom. So that's still this, but now I have pi times 3 squared. And so what I get is that this pi and this pi cancel. So what I have is the angle, pi over 2, times 9 over 2. So 1/2 the angle times the radius squared. And that's because here I have just a pi, and I'm always going to be dividing by 2 pi, so that's always going to yield 1/2. So I'm always going to get 1/2 times the angle times the radius squared. Okay, so if I'm asked for a circumference, and let's say I'm given that the radius is 3, then the circumference is 2 times pi times 3 is 6 pi. If I'm asked for the length of an arc in this same circle, so we're just going to stick with radius is 3. If I'm asked for the length of an arc where the included angle equals, say, 4 pi over 3. So that's actually more than 180 degrees. That's going to look like this around. Then all I have to do is 4 pi over 3 times 3. Angle, radius. 3's cancel, 4 pi. Done. If I want to know the area of the whole circle, it's 9 pi. If I want to know a sector, which this would normally be the sectors, the included angle, but if I told you I need the sector and the angle needs to be 4 pi over 3, then you'll know it's one of these kind of weird situations, these bigger ones. And if I asked you for that, then you would just do 1/2 times the angle, 4 pi over 3, times r squared. 9 over 3 is 3, 4 over 2 is 2, so 2 times 3 times pi, and that's your answer. So again, radius, diameter, chord, center, arc, sector. These are kind of vocabulary for circle. So I'm going to stop this here, and if you have any questions about this, well, you can come on Monday, or you can send me a message through Canvas.